back, students, to one more session of your CBSE grade 12th 2020 board practical VIVA questions. Right, so as I have promised, after my busy schedule today, I just shooted the video for you all, and I've kept in the early morning that I'll be posting the video that is at 9 a.m. but that was a small mistake. Do correct it. So 9 p.m. the video will be uploaded. 9:30. Please watch the videos. So let us learn. I think before watching this video, you need to watch the earlier videos. You need to see that how to answer the VIVA questions, how to come into the lab, how you have to keep your board listen record and your lab record as well as project file. All these I have done a video that how to get scored 30 out of 30 in the earlier or in your board examination without any confusion. What are do's, what are don'ts. So here in this video now we are going to just learn about the different VIVA questions, how you should answer to your teacher. Let's start off. Right. So first important thing, as soon as you enter your lab, everything, once you're settled, if your teacher comes out and calls your roll number and asks you to ask you different VIVA questions, remember, understand, I'll give you a basic idea how to do. Let me take out this heading. Right, so basically your teacher may ask you questions. As I said, it may be from your theory exams, it may be from your part 1 book, part 2 book. Suppose if she is asking generally, let's see. So always the first category or the easiest way or the flame test to find out. So remember this, almost 5 cations you can know. So why do we do flame test? Basically flame test is something we do, important thing, because we kept it in the preliminary test. This will help us to identify the metals and certain metalloids also. Okay, so taking this flame test, what can I do? Just see, in this flame test, basically different colors. You know the procedure. I think I have already told the procedure, what to do, what actually is the flame test, everything. Go through the procedures. Right, students, let me adjust my camera a little bit. I think it is, yeah. Right, so in the flame test, as I said, we'll be testing for the metals as well as certain metalloids. So what are the things your teacher may ask after doing the procedure? What is the color of the flame observed? Remember, this is a simpler one. If it is a potassium salt, compulsory you will get a lilac color flame. Suppose if it is a sodium salt, if suppose you got a sodium salt, it is compulsory in yellow color flame. Suppose if it is a lithium salt, it is compulsory a crimson color flame. These are all the colors which you are going to ask. Suppose if it is a calcium salt, the color of the flame is red. Suppose if it is copper salt's color salts they will not give you, but it would be blue color, which would be a VIVA question. So you need to remember the basic flame colors for your board VIVA questions. So after doing the flame test, if she asks in the VIVA, what is the potassium color? This color. Sodium which color? Yellow. Lithium which color? Crimson. As well as calcium is red in color, as well as copper in blue in color. Done, students? Simple. Now let us erase off this and come back to the next one. You need to just remember based on their gases. So let me erase this. I think first thing about the flame test, if they ask you this thing, you can just simply answer the question. Now after this, next, if I have to if I have to ask, you have to remember certain gases. Let us make one table. What are the different gases? So when I have to speak in the lab, the different gases, we will learn the different gases. There will be different gases which are evolved, isn't it? This is where students can identify very keenly. What are the different gases which we observe? Basically, we observe the evolution of carbon dioxide gas. How to test this? We observe the evolution of sulfur dioxide gas. We observe the evolution of H2S gas. Correct, students? Carbon dioxide, sulfur dioxide, H2S, NO2, like that. Let us see how to simply identify them. Okay, let me move the board a little bit. Okay, so the gases which are evolved are carbon dioxide, sulfur dioxide, H2S, NO2, acetate as a gas, chloride, bromide, iodide, like that, isn't it? Even hydrogen, oxygen also. Suppose if this is given, the teacher is going to ask you a VIVA question. How do you test the carbon dioxide gas? How is it tested? First initial thing, when carbon dioxide gas is released, when you're testing carbonate ion, if the carbon dioxide gas is released, how is it observed? What is the indication? Remember, carbon dioxide and sulfur dioxide and H2S, all three are, first important thing you need to remember are, they are colorless gases. Both are colorless. Now how can I differentiate between these two? Remember, for carbonate, if I have to take, or carbon dioxide if I have to take, it is an odorless gas. There is no odor to the gas evolved. Suppose if it is sulfur dioxide, yeah, you get a choking smell, means you feel that there is something stuck in your throat, you'll be doing some sort of choking, some obstruction will be there in your throat, some choking smell, some sort of irritation. If it is H2S, the salt or the this one smell, this is for the eyes, the eye vision, colorless, and this is for your nose, your very strong nose. You need to sense that. Suppose if H2 is there, you'll find rotten egg smell. So this is done. Both, all the three gases you can test. Suppose if I have to take the same gas and I have to further test it. Okay students, if I have to further test it, I take the same thing, I feel that I got some colorless, odorless gas, carbon dioxide, I need to further test. I got sulfur dioxide, colorless as well as choking smell, I need to further test. H2S, colorless, rotten egg smell. What we are going to do, you are going to take the same colorless gas, that is your carbon dioxide. I am doing the next step. Take the same and send it through lime water. This is what you have studied, isn't it? So immediately what happens, the lime water turns, she'll ask you, okay, you have got carbon dioxide, that is colorless, odorless gas. What will you do further? You're going to take, you said I'll send it through, pass it to lime water. What will you get? You will get a white PPT. So lime water, the carbon dioxide gas, whatever is there, it's going to turn lime water milky. Right, white PPT, lime water, milky. So that is the confirmation for carbonate ion. Suppose if it is sulfur dioxide, what did we get? We said colorless and choking smell. That was the thing. Now what are you going to do? You're going to take the same sulfur dioxide, you are going to send it through acidified KMnO4. Okay, acidified KMnO4, an oxidizing agent KMnO4. When you send, immediately what is the color of KMnO4? It's going to turn purple. The color of KMnO4 is purple. It's going to turn white in color. Remember this. So three gases important: carbon dioxide, sulfur dioxide, H2S. This carbon dioxide turns lime water milky. Sulfur dioxide turns acidified KMnO4. From purple it's going to turn into white. Suppose if I have H2S, what is the smell we have got? We have got colorless gas with rotten egg smell. Correct students? Right. So rotten egg smell, that with that only you can say, okay ma'am, there is sulfur in the given salt. Right. Now let us take next set of gases. Here again I am going to take two important things, that is nitrogen dioxide and acetate. Then we'll go with the halogens. Let us rub this. Next set which I am going to take. So first is over now. Carbon dioxide, sulfur dioxide as well as H2S. Now when I take nitrogen dioxide gas, suppose if I get nitrogen after testing it with the salt you're finding with copper turnings, let us write that. Nitrogen dioxide and acetate. So how will I say there is the nitrogen dioxide gas is released or nitrate is present in that? Because nitrogen dioxide gas release means nitrate is present in that. Vinegar smell means acetate is present in that. So nitrogen dioxide gas, I can easily see with my eyes that it is a light brown gas. Remember, light brown gas. How will this intensify? When you put copper turnings into this, when you put copper turnings, immediately the brown fumes intensify. So light brown fumes, light brown fumes is the indication for your release of your or presence of your nitrate ion as well as nitrogen gas. Suppose if I have to take acetate, first important thing, smell of vinegar. Smell of vinegar, when you take that this in and test it with your nose, smell of vinegar indicates this is acetate. You can easily test your in the senses, easily it can hold that vinegar smell. We use it also, you have it in your house also, students, vinegar. We use it for cooking vinegar, correct? So you can smell that and record that smell and go. After this, now what are over? Carbon dioxide gas over, sulfur dioxide is over, hydrogen sulfide is over, NO2 is over, acetate is over. Now let us come back to now halogens. So in the halogen section, what are there? We have chloride. Suppose if it is chloride, if it is bromide, if it is iodide, your teacher will ask you, okay, what is the what have you tested? How did you know the color of the gas is like that? You can say your teacher or your examiner, chloride I could see, or when it is evolved, I could see pale green color gas, pale green color gas. How was it? You could feel that choking smell. Means again the same thing like what did we learn in sulfur dioxide also. So choking smell was there. You can say pale green. If she asks you bromine, how did you test? You can say bromine, the color was reddish brown fumes. Reddish brown fumes was the color, ma'am. So this is how you have said. Then iodine, violet pungent fumes. This is the halogen color, violet pungent smell. Violet pungent smell. Okay students, so these are the bio questions for the different gases. Chloride would be pale green, bromine would be reddish brown, iodine would be violet pungent. Suppose if the teacher further asks, how can you test this further? What you can do is, you can take this pale green choking smell, this one, that particular test tube, hold one damp litmus paper, hold it like this. Damp litmus paper is what you should take always. Wet the litmus paper and put it in at the mouth of this test tube. Then what you will get, the pale green means the chloride. For the confirmation, how can you get the paper, whatever paper you are this one, the paper is blenched white, it will become white. If you are taking pink, it becomes white. So white indicates, the damp litmus paper, if it turns white, it indicates chloride is present. Understood students? That is what. And suppose if I take bromine, I am getting reddish brown papers. How can I further confirm it? When you add MnO2, manganese dioxide, the reddish brown papers, it starts intensifying. Same is the case with bromine and iodine. So once again, for chloride, you are going to take a moist litmus paper, damp that is, and when you introduce the mouth of the test tube, what do you get? You get the paper becomes blenched white. And if I have to test bromine and iodine, what will I do? I'm going to take MnO2, I'm going to introduce into this test tube, the reddish brown fumes or the violet pungent fumes, they start intensifying, they become more. But here don't get confused, bromine is reddish brown fumes and iodine is violet smell. Right students, now till now what did we learn? We have learned carbon dioxide, sulfur dioxide, H2S, NO2, acetate, chloride, bromide, iodide. Now let us take one more. Hydrogen gas and oxygen gas. It's simple. What is the first indication for hydrogen gas? Hydrogen gas and oxygen both are what set of gases? Both are colorless and odorless. Colorless and odorless. Correct students? Colorless and odorless. Done. So how are you going to test? So for hydrogen, you're going to hold on splinter. The burning splinter will be there, right? That splinter you will take, you will hold it. Immediately, if hydrogen gas is present, what you will get? You get a squeaky sound, isn't it? Squeaky, the pop sound you get, isn't it? So pop, squeaky pop sound you get when you hold. A pop sound sort of thing, just like your crackers pop, 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 it pops, no? You get a pop sound. Suppose if oxygen is there, right? So you hold a splinter, what it does, it relights the splinter. Means if oxygen, the splinter is off also, it relights the splinter. It relights splinter. You understood students? If it is hydrogen, it's going to show the pop sound as well as it is colorless and odorless. Suppose if it is oxygen, it relights the splinter. Right students? Yes. So this is about the gases. Let us come back and see one more. Now what? Till now I have learned flame test, how to do. I can answer flame test questions. Then I can answer different gases questions. Now let us see further the questions. Now we have seen the flame test. Then we have seen the gases evolved. Different gases we have spoke about, like carbon dioxide, sulfur dioxide, H2S, NO2, hydrogen, oxygen, halogens, acetate. Now we will go to the next step, that is your wet test. Now in lime water, in the wet test, we are going to take the salt solution. Now basically all the anions, whatever are there, we need to test. So I'll tell you one simple thing. Suppose if you have taken that particular salt solution, okay, now we'll study in sets. What is that set? We will learn it in for example, carbonate. First carbonate, you have got, you're testing for carbonate. So when you're testing for carbonate, CO3 minus 2, one thing you need to remember, take that salt solution. Salt, SS stands for salt solution. You're going to add to this dilute acid. Simple, isn't it? Take the test tube, add dilute acid. Suppose if carbonate is present, what is evolved? I told you carbon dioxide. What is the color of carbon dioxide? Colorless and odorless. What should you do? You need to take, put it in lime water. So lime water, what is the color it's going to change? It's going to change into milky white. Means it turns lime water milky. Correct? Once again, take the suppose if it is carbonate, you need to take the salt solution, correct students? Then you need to just see, add the dilute acid, you get carbon dioxide evolution, and then you can add lime water, send that carbon dioxide gas into lime water, it turns lime water milky. This is over. One understanding. Carbonate I understand, you can report and write it as anion, carbonate anion. Suppose if you are feeling that this chloride, bromide or iodide, what is the color of chloride, bromide and iodide? I said in the earlier this one also. Chloride, bromide, iodide. Chloride is pale green, bromide is reddish brown, iodide is violet. Yes student? Yes. So right. So here what are you going to do for all the three? Let us assume anything is present. You are observing the flame color. You are going to add nitric acid to this. Along with this nitric acid, what are you going to add? You are going to add aqueous silver nitrate. Suppose if chloride is there, what color? This is what I am going to add. Suppose if chloride is there, I will be getting which color? Whenever I add these two in the test tube, I will be getting white PPT. If bromide is there, I will be getting cream PPT. Cream PPT. If iodide is present in the salt, you get in low PPT. This is an easiest way to answer your teacher and easiest way to perform also. Right students? Easiest way to answer as well as easiest way to perform. So first thing, it's over. What is the thing? I have tested, means carbonate I got. Now chloride, bromide, iodide also is over. With this you can just say, ma'am, this is the color I observe with nitric acid and aqueous silver nitrate, and this confirms, and you can further, if she asks you, do the chromyl chloride test, like that, go further. But basic confirmation, you can start writing the procedure. You can just do the confirmatory test whichever you feel and finish off. This is over students. Now let me give you information about two things again, one more. After this is over, then let us think how to test sulfate and how to test sulfite. These two where the students get confused. So both, for the first one, for the sulfate, what you're going to do, you're going to add aqueous HNO3 as well as aqueous barium nitrate. Aqueous HNO3 as well as aqueous barium nitrate. So when you take this aqueous HNO3, aqueous barium nitrate, and for sulfite, what are you going to do? You're going to add dilute HCl as well as you're going to warm it gently. Dilute HCl and you're going to warm gently. This is the basic thing. So if it is sulfate, what will happen? You get a white PPT here in the first case. What you get? White PPT in the first case. If it is sulfite, you're going to get, means what we can do is, this whatever sulfur dioxide gas, when you're adding dilute HCl and warming it, no, sulfur dioxide gas will come out. That sulfur dioxide gas, what does it do? It's going to turn acidified KMnO4 purple to colorless. Once again students, if it is sulfate in your salt, when you add aqueous nitric acid as well as aqueous barium nitrate, what will happen? Immediately there's a formation of white color PPT. Okay students, suppose if you are having sulfite and you are adding dilute HCl, what do you get? Means how can I further test it? I can further test it by adding acidified KMnO4. So acidified KMnO4, when I add, what will I get? I'm going to see that potassium nitrate from purple, color of potassium nitrate is purple. From purple it's going to turn colorless. Simple. So what did I teach you? I have taught you how to test carbonate, I have taught you how to test halogens, I have taught you how to test sulfate, how to test sulfite also. Yes students, right. Now let me come back and give you one more clue for your VIVA. Simple, because you in a VIVA maximum you will be getting 5 minutes or to 7 minutes to answer. So understand that. Now suppose this is also over. I know about gases, I know about solutions. Now let me come back. Now I know about the anions also. Now let me take the cations. Now cations, when we see, only two things we have to remember. What? One column, try to make it for aqueous with column with aqueous sodium hydroxide. One more column try to make it with aqueous ammonia. These two things only is basic for cations, you can understand. So if I have cations, okay, if soluble, insoluble, let's see. Suppose if I take aqueous sodium hydroxide and add it to this, understand, aluminium is one cation. Aluminium is one cation, Al plus 3, which is soluble in aqueous NaOH. What is it students? First of all, what is the color of aluminium which is formed? It's nothing but white PPT, isn't it? Right, when you add, so white PPT you will get. So aqueous aluminium is soluble in aqueous sodium hydroxide. I'll write soluble. Suppose if I take aqueous ammonia, this aluminium Al plus 3 ion is insoluble, Is insoluble. So both are white PPTs. White PPT formed is soluble in aqueous ammonia. It is insoluble in aqueous ammonia. Next cation let's take. Suppose if I take zinc. Again zinc also forms which color PPT with aqueous? Sodium hydroxide. It also forms white PPT only. But this white PPT, what happens when you're dropping in? So this in white PPT is soluble in aqueous sodium hydroxide. Here also Zn plus 2 is soluble in aqueous ammonia. Done, students. I know about two cations now. Let me take next cation, that is your calcium. Okay, let me take the calcium and right. Now when I take calcium, Ca plus 2, again here also same white PPT. Calcium cation, always remember, it is Is, insoluble in aqueous sodium hydroxide. And basically calcium, there is no PPT formed in aqueous, very slight PPT. So I'll almost write no PPT. Calcium is over. What is the next test? Chromium. Right, let me write. So after calcium, the next cation which I can test is chromium, Cr plus 3. So chromium, what is the color? Again it is white PPT, all are white PPTs. Here when I take chromium is soluble in aqueous sodium hydroxide and chromium is insoluble in aqueous ammonia. You have to tell your teacher, she'll ask you which is soluble in aqueous ammonia, which is not soluble. Right, students, let me erase this. Hope you would have noted it. Right, and next thing, next cations. What is the next cation? I am left with Fe plus 2 ammonia also. Let us write. So next cation, aqueous sodium hydroxide and aqueous ammonia. Suppose if I take Fe plus 2, right, Fe plus 2 here also. So Fe plus 2 is insoluble in aqueous ammonia. It is also insoluble in aqueous sodium hydroxide, insoluble in aqueous ammonia also. Suppose if I have to take Fe plus 3, what is the color of the precipitate form? The color of the precipitate form is reddish brown. This reddish brown PPT, it is insoluble in both. Even in aqueous ammonia also, even in aqueous sodium hydroxide also, it's insoluble. So remember, iron salts are insoluble in aqueous ammonia as well as aqueous sodium hydroxide. Remember that clue. Now suppose I'm getting ammonium. Iron is over, zinc is over, calcium is over, aluminium is over. Now suppose if I'm getting ammonium, how can I test directly, ma'am? Simple. Suppose if you feel that you have got ammonium cation, we confirm it with the Nestler's reagent, isn't it? But here, simple. Once you feel that ammonia is confirmed, means, or once you feel that ammonia is tested, means ammonia, you have got ammonia. Right, ammonical smell you see, right? Then what you do, you take a damp litmus paper. She'll ask you easiest way to do. Damp litmus, red litmus paper you take, moist, wet it. Most of the students, they don't do the moistening part. You will not get the results, students. You have studied in grade 10th, isn't it? That is where the flow of H plus ions will be there. So damp the litmus paper. What will happen to the litmus paper? If it is ammonia, the litmus paper turns blue because it is a base, isn't it? So this is one test for ammonia. Right, so I have taught you about the gases questions, I have taught you about the flame test questions, I have taught you about the anions, I have taught you about the cations, correct? Now let us come back to the next page, students. Right, so smell, I could see, I could test the color with my eyes, I could also say which cation is what. Right, let me come back and start with the next question, that is the next VIVA question, which is important. She may ask you, the examiner may ask you from anywhere, so let me start with that one. Right, so here the next part, when we take, let us erase this. Right, so the next VIVA question, she'll give you options. What she'll give you? She will give you different options like NO2 minus is one option, comma iodine minus. She will ask you SO3 minus 2 and carbonate minus 2. She will give you one more set, carbonate minus 2 as well as chloride minus. She will give one more set, bromide minus and iodine minus. She may ask you like this, among all these, which are decomposed by dilute HCl? If this question is asked to you, which are decomposed by dilute HCl, remember only SO3 minus 2 as well as carbonate are decomposed by dilute HCl. Remember, I am writing here decomposed by dilute HCl. Dilute HCl. This is one Viva question. Now, next question. The examiner, hope you would have noted, students. Right, I am erasing it. Right? Now, next question which they are going to ask is, she'll ask you, name 2 colorless gases formed with dense white fumes. So, what are the 2 colorless gases? So, let us write, okay, name 2 colorless gases with which one? On mixing forms. Colorless gases on mixing forms, dense white fumes. Dense white fumes. So she will give you the options like first option would be ammonia and oxygen. Second option would be SO2 and steam. Third option would be ammonia and HCl. Fourth option would be ammonia and HNO2. Okay, so remember, when I mix 2 gases I get dense white fumes. What are the 2 dense white fumes? It is nothing but ammonia and HCl. Remember this. Right, this is one important question, Viva question. Even I have asked this question also in the exam. So remember, let us do one more Viva question. Same question, name 2 colorless gases with white color I gave, no? I will erase all the options and I will ask the same question in a different way. Name 2 colorless gases, because both are options colorless gases. On mixing gives which one? Deep brown gas. Deep brown gas. So if she asks you deep brown gas, what is a colorless gas? Again she will give you an option. NO2 and O2, one option. She may give you, or he may give you one more option, N2O and NO. Next option would be NO and O2. Next option would be NH3 and HCl. This is useful for your JEE also, students, right? So the 2 colorless gases we have already studied. What are the 2 colorless gases? We have studied initially colorless, odorless, like this, right? So the option, correct option which gives deep brown gas is nothing but NO and O2. Remember this. This is one more important Viva questions which you should know for your entrance exam also. Right, student? Right. Now let us erase off. One more Viva question we'll see. Next question is how to identify or how to differentiate carbonate and sulfite, okay, as ions. Right? What is that? Suppose if they ask you, simple way I'm saying, she'll ask you how to differentiate CO3 and how to differentiate SO3 minus 2. Simple, tell me one common test. So here, simple. First you're going to take K2Cr2O7 in both. Suppose if there is carbonate, right, what is the gas evolved? The gas evolved is carbon dioxide, right? If this is there, what is the gas evolved? The gas evolved is sulfur dioxide, correct? When this is present, when you add this potassium dichromate, there is no green color observed. No green color observed. Suppose if sulfur dioxide gas is there, you are adding K2Cr2O7. Green color gas is observed. Green color gas, no, green color is observed. Means the tinge of the gas. Here if it is carbonate with same potassium dichromate, no green color is observed, but here green color is observed. Remember that. Same thing, students. Suppose if I have to ask, if she asks me carbonate, sulfate, O. If she asks me difference between NO2 minus as well as NO3 minus, what you should remember? The same concept with potassium dichromate. The same concept like potassium dichromate. Suppose if I take dilute acid and add to this both. See, if NO2 is present, what do you get? I get brown. Let me erase this. I'm going to get brown fumes. And here with dilute acid, no, does not observe, nothing is observed. Right, students? Now, next thing. Let me erase this. Next question. What are the cations which do which among all these, which is a cation which does not show flame test? Let me write the question. Which cation does not give flame test? So only one answer. All the flame tests we have seen, potassium we have seen, lithium we have seen, calcium we have seen. If she gives me the options among calcium, if she gives me options around beryllium, if she gives me barium, if she gives on about beryllium and strontium, which is a cation which does not show flame test, beryllium is option. Remember, beryllium is an option. Beryllium cation does not give flame test. Don't give a different color there. It does not respond to flame test. Yes, students? Right. Now let us take out next question. Suppose if she asks you why, this is a very quite common question, why silver plus Hg plus 2 Pb plus 2, why they are grouped under first group? Why is it given? Why are they grouped? Let me write that question. Why Ag plus Hg plus 2 Pb plus 2 are grouped in first, or why are they grouped in a first group? So why? Basically, how are they precipitating? First you should know. Are they precipitating as sulfates, or they precipitating as chlorides? Are they precipitating as hydroxides, or are they precipitating as carbonates? So remember, students, among all these, if I have to take, why these are grouped, why these are given under first group? Because you have to answer, ma'am, silver, mercury as well as lead, they precipitate as chlorides in first group, because the group reagent here we add is dilute HCl, isn't it? Dilute HCl is a group reagent, ma'am. That's the reason they precipitate as first group, or they precipitate in first group. Yes, students? So remember this VIVA question. Next, there's one more question which I have asked in my exam. Let me write that. I have asked them what is the alkaline solution of potassium mercuric iodide? What is that? Let us write. What is the alkaline solution of potassium mercuric iodide? So what is potassium mercuric iodide? It is nothing but Nessler's reagent, no? It is nothing but Nessler's reagent. Where we are using, this is used as a confirmatory test while testing ammonia or the zero group. And she may ask you, in Nessler's reagent, what is the active ion? In the potassium mercuric iodide, what is an active ion? The active ion present here is HgI4 minus 2. This is the active ion present. So in potassium mercuric iodide, this particular composition is the active ion present in Nessler's reagent. Done, students? I think I've given lot of VIVA questions. Now let me add some more VIVA questions to the last page of this. It will be useful for your salt analysis. I'll be very soon doing again volumetric analysis also. Right, students? So last page again, I think almost I'll be sending you a scanned copy. I have written very neatly all the questions, almost how many 10 questions extra I'll be sending. So thank you for watching, students. Believe in yourself. Remember,